Hello, friends. Steve Delamarter. I'm here with Dr. Ralph Lee. We want to talk today about best representative manuscripts, give another sort of introduction. You'll find in a different video a more basic introduction. In this one, I have to warn you at the outset, we're going to get out into the weeds. If you want to understand the logic behind the best representative manuscripts and how the statistics are generated and how we might then modify the statistics with human judgment, we're going to have to walk you through this process. It begins on our dendrograms with this line of stars that are on the dendrograms. And they are there because in order to designate for each cluster the best representative of those clusters. And it turns out that not every star means exactly the same thing. And to understand what these judgments about the best representatives are and how they're produced, we got to walk you through those calculations so that you can make your own judgments about the validity of that.
Yeah, so why do we want to know this and what is it for? Again, the background is always that we're trying to tell the story, narrate the history of the text. And this tool allows us to look at a smaller set of manuscripts in order to see still the complete range of text types.
Yeah, and that means that in the book of Hosea, in the end, instead of having to look at all 34 manuscripts, we can narrow it down to just these few and see the full range of options given to us.
Yeah, and we need to understand that by their nature, some best representative texts will be more valuable than others, and that's a part of the process of making the choice that we'll explain. So what do we mean by the term best representatives? Well, it's what we define it as. It's a convention based on a formula, and we need to understand the formula so that you can understand the concept properly. So we're going to go through some steps now to help us understand that.
Very good. The judgment about clusters represents our working hypothesis. So we start out with a dendrogram that doesn't have any boxes, and we're the ones that create these boxes. And some of them are easy to do, like these ones here. This one, we'll talk about more later, is harder to make a case that that's a real cluster. In fact, it's not. It's a pseudo cluster. But there's manuscripts you could have divided it here into, 2 and 2. So we want to be right up front in showing that these are judgment calls that we make, and they represent our working hypothesis. And what's going to happen is that we're going to take that working hypothesis and apply it to the data. But right at the outset, we want to ask ourselves a question, well, what would be the nature of the evidence that would prove that our working hypothesis has validity? Well, the behind this working hypothesis is this set of assumptions. Every time we get to a fork in the road and there's a little distance between what's underneath the fork, what causes that is that there is a list of distinctive readings that distinguish this cluster from this cluster. And so the nature of the evidence that would prove our working hypothesis has validity is to find those lists. And it is precisely those lists that distinguish not only the big superclusters from one another, but then every other fork in the road to distinguish even these very small. This is going to be a very small list. This is going to be a large list, just based on the percent difference represented by these. So for every cluster, there is a list of shared variance that stands over against the other clusters. And we acknowledge right at the outset that this is kind of a circular reasoning, to be sure. In response, this is a fundamental characteristic of any and all truth systems or explanatory models, that data and conclusions lie in mutually defining relationship to one another. And in the end, it will be the elegance and the explanatory power of the model that convinces you that it's a good working hypothesis that actually explains the data. Here's how that actually works for us in terms of the processing of the data. We start with this really important spreadsheet, our data sheet. This is the data that results from the THEOT scripts that are applied to the data. And this first spreadsheet is the single most important one. It's the foundation of all of our data. It's a spreadsheet that in this particular case is 1,717 lines long. That's because there are 1,717 columns into which we've aligned all of the text from all of the manuscripts in the sample. There are 34 manuscripts in the sample. 34 times 1,717 is about 58,000. There are 58,000 data points in this spreadsheet in which we identify whether the manuscript has the word in the column or doesn't have the word in the column. Hidden within this 58,000 data points is all the data that's available to us about textual variation, at least from the statistical viewpoint. So it's a huge data set, but it's completely inscrutable. You look down through this spreadsheet and you say, I see all those ones and twos, but I don't know what it means. And you can't at this point until we further process the data. And in this case, then, we take and give to the computer our working hypothesis. We tell it for EA1, these 5 manuscripts constitute the cluster we're calling earliest attested 1. And these 4 manuscripts constitute the cluster that we're calling earliest attested 2, and likewise down through. So now the computer script has available to it our working hypothesis about the clusters. And it says, okay, thank you. Given that, then I'm going to go give you the cluster profiles. What does that mean? I'm going to go through all 1,700 lines of or columns of text and find the pattern for each cluster, what the usual reading is for the cluster. And that means then we can take this data about the cluster profiles and click it onto the end of the spreadsheet that we made over there, so that now we have the profiles of the individual manuscripts alongside the profile of the cluster reading. And that means then in a next step, we can run the percentages. And this time, instead of just designating what degree of affinity manuscript 1 has with manuscript 2 or manuscript 3 has with manuscript 8, now we can say how much affinity does manuscript 1 have with the cluster 1 profile and with the cluster 2 profile. So it's really this part of this spreadsheet that is giving us now, telling us how closely related each manuscript is to each cluster, how much it shares the reading of the cluster profile. That then, in this amazing moment, we press a button and out pops this report. This is the final step in this process in which the script it takes a look at every manuscript in all 34 manuscripts and tells us what their proximity is to the cluster profile of cluster 1 and cluster 2. And not then surprisingly, it's the manuscripts at the top that are candidates for being designated the best representative. And that's because, for instance, cluster 7, we look here and we see it says EMML 36 from cluster 7 shares the cluster profile 99.4% of the time. Statistically speaking, this manuscript is the best representative of the cluster. And likewise over here in cluster 8, EMML 6686 represents the cluster 99.4% of the time. So this is a magnificent start to the process, designating the best representative for each cluster. So we go through this process to identify the cluster profile, calculate the best representatives of each cluster. Back to you, Ralph.
Okay, so again, sort of summarizing, what are we doing to identify the best representative manuscripts? We identify the cluster profiles. We calculate the best representative of each cluster. We need to understand 2 further things to really get the foundations of this concept. First, point is that clusters that have only 2 manuscripts, then actually both manuscripts will turn out to have represent the cluster 100% according to the formula that we've defined. That's not problematic. It's just a feature of the way that the maths works. And here examples are cluster 9, lat V, and cluster 6, stand 2, both cases where there are 2 manuscripts. So the methodology we've used to choose the best representative there is something else, and we'll come back to that. Finally, a point to note is seen in cluster 3, EA3, which is a pseudo cluster. We haven't chosen to designate a best representative there because it is a pseudo cluster, and so the concept isn't meaningful really for that particular group of manuscripts.
Um, when we run this calculation of the best representatives, it shows us, as I mentioned, the contenders for the best representative. And this is merely, as you see now, a statistical profile. And there are 2 reasons why the manuscript that shows up at the top might not be actually the best representative of the cluster. What would that be? There are 2 reasons. Number one, if the manuscript is lacunos, if there's some pages missing or it has damage to it, we wouldn't want to use that as the best representative, even if what's left highly aligns itself with the cluster. The second reason is if the scribe tends to be idiosyncratic and have idiosyncratic readings. Well, how would we know the answer to those 2 questions? And it turns out quite easily. We have another tab called the Statistics tab of data, which gives us precisely the information we need to answer that question. If in that data sheet a manuscript is missing, we can't tell what the reading is. It doesn't get either a 1 or a 2. It gets a 0. And then in this statistics tab, we can go through and quickly count how many times does a manuscript have a 0 in it. Here's the worst offender. GG 181 has several pages missing, and consequently, in 593 of the 1,717 columns, it has a 0. So no matter if what's left aligns really closely with the cluster profile, we're not going to use it as the best representative. Likewise, we see the same kind of a phenomena with EMML 8934 with 235. And likewise, EMIP 654, which has 341. So once we get past those pretty bad and beat up manuscripts, we get down to numbers that are acceptable. So that helps us make judgments about whether or not we ought to use a manuscript based on the condition of the manuscript. This other tab, there's a digital fingerprint for scribal idiosyncrasy in the data. And when it is the only manuscript that has a reading in a column, then we can summarize how many times that happens. The worst offender in this case for scribal idiosyncrasy is EMIP 1029 with 21 acts of scribal idiosyncrasy. So we say, hey, if EMAP 1029 shows up at the top of the list, we're probably not going to use it because it has so many scribal idiosyncrasies in it that it wouldn't be the best representative. What we're trying to illustrate here is that we know their judgment call has to be made between the merely statistical report and then what we learn about the manuscript from these 2 other sources. So in the end, we make a final judgment, but it is the interplay between like the statistics and the human judgment.
So, beginning, this is all about telling the story of the textual history. So, what is this? How is this helping us, and what does it teach us? We learn there's a path from a large collection, a plethora of manuscripts, towards a much smaller set of manuscripts that represent the readings of all the major clusters, and that's a really useful tool for homing in quickly from the mass of data. The significance of the best representative is that it's a real manuscript with real readings that represent a host of other actual manuscripts. This is in contrast to what you might generate in a critical study and a critically reconstructed text, where actually you end up with a text that doesn't represent any of the manuscripts. So the best representative concept is ideal for this sort of work that we're doing, where we're studying the emergence of the text in the textual history, and the latter is perfect for the study of origins of the tradition.
So this is a final thing we'll just emphasize at the end here. This is one of the things that in our minds distinguishes this field of textual history, which studies the emergence of the tradition across time, as opposed to the study that focuses on the origins of the tradition. The origins of the tradition moves further and further and further towards a reconstructed text, which unfortunately doesn't actually exist, doesn't represent any manuscript that we have. And that's valid for what it does, but it's completely different from and will never give you a feel for that reconstructed text, will never give you a feel for the textual history, for the outworking, the emergence of text across time. And now you can't talk about the text, you have to talk about the texts, the manuscripts. In this regard, best representatives represent real manuscripts that represent real clusters and is sort of the opposite of what you have on the other end of it. Both of these have validity, but we're looking for the one that is most relevant for the study of emergence in textual history. Thank you for your time and for going into the weeds with us. We hope this has been a help.